notice, and this is a typical copyright. We continue mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Right now, I am slightly behind because I should have had these 33 videos for September 2024 on number theory and computation published on YouTube, but I am a few videos behind. However, by October 2024, I'm hoping to catch up with those few videos up there that I'm behind with and complete the 13 to 15 videos on consumer arithmetic. Then November 2024, sets, December 2024, measurements, January 2025, statistics, February 2025, algebra, March, relations, functions, and graphs, April, geometry and trigonometry, and by May, hopefully mid-May 2025, vectors and matrices. As I said before, I have divided section 1 into 33 videos, all of which will be made available on YouTube in their entirety. Reminder again that this section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. So please make sure you view these 33 videos from section 1 carefully and then decide if you will go on with the rest of the syllabus. As already pointed out, these 16 videos here have been published, completed and published on YouTube. And so far, we are finished with up to here, all of those, up to 28. We are now at video 29, which is the second part of objective 13. We still have 4 more videos to do after this one. So this objective, as you already know, says express one quantity as a fraction or percentage, make that and, of another. We did that in the first of the 2 videos, and then the second part says comparing 2 quantities using fractions and percentages. So we did that part already, and now we are doing this second part, compare 2 quantities using fractions and percentages. So let's begin with comparing them using fractions first. We will look at 4 such examples, and then we will look at those same 4 examples, but in terms of percentages. Example 1. In test 1, Akan got 13 out of 15 marks, while in test 2, she got 17 out of 20 marks. In which test did she do better? So what we have to do is we have to express both test scores as fractions. And then we will find the LCM of both of the denominators and begin as if we were about to add the fractions. But of course, we will not put in the addition sign. When we do that, we will be expressing those fractions with a common denominator. So let's look at this one, how it goes. In test 1, it is 13 out of 15. No problem with that. And in test 2, it is 17 out of 20. So far, so good. We will treat those 2 fractions as if though we are going to add them So, but we will leave out the addition sign. So we put a line down here and we write the LCM down here, 15 and 20. The LCM is 60. So you know how this goes. 15 into 60, 4 times 13 is 52. And then 20 into 60, 3 times 17 is 51. So now 15 over 30 is actually 52 over 60. And 17 over 20 is actually 51 over 60. So which one is greater when you see them now both over 60? This one, of course. So Akan did better on or in test 1. And that is what we will do for the next 3 examples. And I think that will be enough for us to be able to compare 2 quantities using fractions. Okay, so that was example 1. Example 2. Richard bought a math textbook for $20 and sold it for $25. He also bought a physics book for $50 and sold it for $62. Which sale gave him a better rate of return? Not more profit. Because if he bought the math book for $20 and sold it for $25, he got a profit of $5 there. And when he bought the physics book for $50 and sold it for $62, he got a profit of $12 there. That's not what we're talking about. In comparison to the money he spent, in which of those 2 situations did he get a better rate of return? So, as I said, we will express both transactions as fractions. Then we will find the LCM of their denominators and begin as if we are about to add the fractions, but we will not write the addition sign. Thereby, we are expressing those fractions with a common denominator. So in the first example for the math book, it was $5 out of 20. And in the second case, it was $12 out of 50, not 62. So let's pretend that we are going to add those. What is the LCM of 20 and 50? It's 100. So 20 into 100 will give us 5. 5 times that 5 up there will give us 25. 50 into 100 will give us 2. 2 times that 12 there will give us 24. So you understand that 5 over 20 is the same as 25 over 100. And 12 over 50 is the same as 24 over 100. Both of them are now on a level playing field. The denominator is 100. So you can see, obviously, that this one here is a better rate of return. Not much better. That one is 25 and the next one is 24, but still better. So the math book sale gave a better rate of return. Okay, now that you know that, for the next 2 examples, that is exactly what we will be doing. Example 3. In cricket match A, Hayden scored 48 runs out of his team's total of 250 runs. In match B, he scored 40 runs out of his team's 200 runs. In which match did he score at a better rate? In comparison, that is, to the overall score for his team. So as we said, we will express both scores as fractions. Then we will find the LCM of their denominators and begin as if we are about to add the fractions, but we will not write the addition sign. And thereby we are expressing those fractions with a common denominator. So for match A, 48 out of 250. Match B, 40 out of 200. Now what is the LCM of 250 and 200? It actually is 1,000. So 250 into 1,000 would give us 4. 4 times 48 will give us 192. 200 into 1,000 will give us 5. 5 times 40 will give us 200. Okay, so you understand that 48 over 250 is the same as 192 over 1,000. And 40 over 200 is the same as 200 over 1,000. So both of them have a common denominator. Now, as you could see, there's a 200 here. So clearly, in match B, he did better in terms of the overall runs that the team made. So Hayden did better overall in match B. That was example 3. We will take one last example on comparing two quantities using fractions. After that, you know how this works. In village Q, 65 of the 80 primary school age children are registered in a school, while in village R, 49 of the 60 primary school age children are registered. Which village has the greater proportion of children attending school? Now we are assuming that because they are registered, they are attending school. So we express both attendances as fractions. We will then find the LCM of both denominators as if we are about to add the fractions, as if, thereby expressing those fractions with a common denominator. So village Q, 65 out of 80, and village R, 49 out of 60. So what is the LCM of 80 and 60? And it works out to be 240. So 80 into 240, you get 3. 3 multiplied by 65, you get 195. Then 60 into 240, you get 4. 4 times 49, you get 196. So again, by now I don't need to tell you this, but 65 over 80 is the same as 195 over 240, while 49 over 60 is the same as 196 over 240. So now that they have a common denominator, we just look at the numbers at the top here, 195 compared to 196, and you can see that even though it's not much more, this here is still better. So village R has a greater proportion of children attending school. If you find this video useful and interesting, please like and share. That is to say, like and share. You may even consider subscribing to this channel. Subscribe, especially as it doesn't cost you anything and it means a lot to me. So now we are going to look at those 4 examples all over again, but now we will deal with them in terms of percentages. Down here, that was when we were looking at fractions. So we are going to look at them now in terms of percentages. And in terms of percentages, you can either express the fraction as percentages, and we already have the fractions over here, or you can express the given data directly as percentages. We will do both of those, as we saw in the last video. Let's look at it as carrying fraction to percent. So the first one is 13 out of 15. You multiply that by 100 and you get 86.6%. And the second one is 17 out of 20. So we are carrying this fraction to a percentage. We multiply by 100% and we get 85.0. So carrying the fraction to percentages, you could see that we have the same answer we got previously when we were dealing with fractions alone. Now, let's carry those quantities directly to percent. And in this case, you will multiply the 13 by 100% and divide by 15. So 13 multiplied by 100% divide by 15, and we get 86.6%, which we should. And test 2, 17 multiply by 100 divide by 20, and we get 85%. So whether you calculate the percent directly or you take the fraction and carry it to a percent, you will still get back the same answer. It does not make a difference. So now we can see that whether we do it by fraction or we do it by percent, you can clearly see that she did better in test 1. Better in test 1. So question 2, remember we are revisiting those questions, but this time we are doing that in terms of percentages. The fraction is already here. And we know that this one was actually the better situation. So as I said, you can express the fraction as percentages, or you can carry the numbers you are given directly to percentages. So first of all, let's express the fraction as percentages. 5 over 20 multiplied by 100 gives you 25%. And 12 over 50 multiplied by 100 gives you 24%. Which percentage is better? That one, of course. That is, if you carry the fraction to percent, but you don't have to do that. You could carry the numbers you are given directly to percent. So you multiply 5, that's the profit on the math book, by 100%, and this 100% always stays as that, always 100%. Divide by 20, and you will get back 25%. And in the next case, 12 multiplied by 100, divide by 50, and you get 24%. So as you could see, whether you work it by fraction, or you carry the fraction to percent, or you calculate the percent directly, it doesn't really matter. Math book sale gave a better rate of return. So we go back to example 3 about this cricket match and Hayden. So as I said, you have 2 ways of doing this. Let's look at the first way, carrying the fraction to percent. So 48 over 250 multiplied by 100, and you get 19.2%. And then 40 over 200 multiplied by 100, and you get 20%. It's not much more, but it is more. As you could see here, go in the fraction way. Now, this percentage way, carrying the fraction to percent, or going directly to percent, 48 multiplied by 100%. Remember, this is standard. It is always 100%. Over the larger number, which is 250, and that works out to 19.2. And then 40 multiplied by 100 over 200, and that works out to 20%. So this one here, we can see, doesn't matter how you calculate the percentage, or if you use the fraction. But C-Sec is you need to know how to do this both ways. They may not actually ask you to do it both ways, but you need to know how to do it both ways. And so Hayden did better overall in match B. And then finally, example 4, this is the last example that we already did, but we are not doing through fractions. We are doing it based on percentages. though we may actually carry the fraction to percent. So we take this fraction, 65 out of 80, multiply by 100%, and you get 81.25%. And then we take the next fraction, 49 out of 60, multiply by 100, and you get 81.67%. As I said, it's not really much more, but village R evidently has the edge. And again, if we do that percent directly, 65 multiplied by 100, remember, always multiply by 100, over the other larger number, which is 80, and that would give you 81.25. And in the next case, it will be 49 multiplied by 100 over 60, and now we get 81.67. So if you calculate the percent by fraction, if you calculate the percent directly, if you compare the numbers based on fractions only, doesn't matter, you will still end up with the same answer. Village R has a greater proportion of children attending school. Well, actually, it's percentage. Now, the objective says you are to compare two quantities using fractions, and you can do that, and percentages. So let's go a little beyond what CXC requires. How about if you had to compare three quantities? I do think by now that I don't have to teach you that because you have seen the trend. However, for those who may not have gotten that yet, let's straighten it out. Let's go back to Akan. In test 1, she did get 13 out of 15 marks. In test 2, she got 17 out of 20 marks, but now we have a test 3 since then, and she got 22 out of 25 marks. In which test did she do the best? Okay, so we will set up these fractions as if though we are about to add them. 13 out of 15, 17 out of 20, 22 out of 25. We'll find the LCM, which is 300. We will divide the 300 by 15, and the answer we get, we will multiply 13 by that, and we get 260. We divide 300 by 20, and the answer we get, we will use that to multiply the 17, and we get 255. And then we divide the 300 by 25, and the answer we get, we will use that to multiply this 22, and we get 264. So now, 13 out of 15 is the same as 260 over 300. And 17 over 20 is the same as 255 over 300. And 22 out of 25 is the same as 264 over 300. Okay, so based on the fraction, you have the answer for that. Let's work the percentage rate. So she did best in test 3, as you can see. Let's go percentage rate. We will take these fractions and carry them to percent. Multiply by 100, you get 86.6. Test 2, 17 over 20, and you get 85.0. And test 3, 22 over 25, and you get 88.0. So whether you go by the fraction or the percent, you can see that she did best in test 3. Now, before I finish this topic, notice that this 86.6% and this 85.0% and this 88.0%, what you have done is that you have also carried them to a common denominator, and the common denominator is 100 because this percent here means out of 100. So 86.6% is 86.6 out of 100. 85.0% is 85.0 out of 100. And 88.0% is 88 out of 100. So when you carry percentage, you are in effect carrying them to a common denominator, and the denominator is always 100. You may not have realized that. I just thought I will point it out. So fraction this way, decimal this way, which is in a sense a type of fraction. It seems easier to compare these quantities using percentages. If you go the LCM way, first of all, it may be difficult to find an LCM. And secondly, once you find that LCM, you have to divide that LCM by 15, and the answer you get, you have to multiply by 3 and then put that down here. Maybe if you have two simple fractions to compare, that will work. But if you have 3 like this or 4, anyway, CXC says you are to know how to compare two quantities. And I think you can manage that now for yourself. So we just completed video 2 in objective 13 of section 1, compare two quantities using fractions and percentages. So we just completed that. And that brings us to the end of video 2 from objective 13 in section 1.